We are on chapter 10, section 6, part 1. So 10.6, part 1. And we are looking at what is a secant. So basically, a secant is a line that passes through the circle at 2 points. Here is a secant. Here is point 1. This is point 1. We'll call it A. Here is point 2. We'll call it B. Here's another secant. We'll call this C, and we'll call this D. Now, some people might ask, well, what's the difference between a secant and a chord? Well, a secant is a line, and a chord is a segment. So here we would have chord AB, and here we would have chord CD. But a piece of it, if I went from this point all the way to the other end of the circle to this point, here we are on another screen. This is Geometer Sketchpad. I sent it to you guys. I don't know if it worked, so please let me know if it's working. So anyway, here I have drawn a circle and two secants that are intersecting. So here is a secant. You could call it XY, secant RB, whatever. And here is another secant. And notice that they are going way through the circle. Okay, so these are not chords. Chords would be from V to C or from X to B. So these are both secants. They start here, they go all the way through the circle and onward. And the only reason they look like segments here is because I can't draw lines, but we're going to assume they're lines. All right. Now let's take a look right over here. This is going to be measuring the angles that are intersecting. This is actually circle W, which is why it says VWX. So VWX is 31 degrees. And BWC is 31 degrees. Okay. And that's what that's looking at. And notice those are vertical angles. And from previous units, you should know that vertical angles are congruent. Also, make sure you keep an eye on the sum. That's the sum of these two angles. That's 31 plus 31 is 62. So we're going to be looking at this sum, 31 and 31. That's 62. Now let's take a look at this part right here. This is the intercepted arcs. Measure of arc CB is 31 degrees. So right here, arc CB is 31 degrees. And measure of arc VX is also 31 degrees. Okay. And notice that the reason that these guys are the same measure is because you have central angles, and central angles and their intercepted arcs are always congruent. So right now, you have this situation and this relationship. And again, keep an eye on the sum. Right now, the sums are the same, sum 62, sum 62. All right, and the angles are the same, 31, 31, 31, 31. That's because right now I'm at the center. So what I'm going to do now is I'm going to move away the angles from the center. Now, this is why it's actually VWX over here and BWC, because I'm measuring these angles over here. I'm measuring these angles, and this is circle R. So I'm going to move this around, and as I'm moving it around, keep an eye out for what's going on over here. Okay. as you can see, the angle section is not moving at all. And that's because I'm not changing those angles at all. So here I still have 31 degrees, and here I have 31 degrees. So that doesn't change at all. But if we look at the intercepted arc, CB is now 28 and VX is now 34. Right? So notice that the arc measurements have changed. Well, the reason they have changed is because these guys right here, they are not central angles. All right? They are not central angles. So when they intercept the arc, you're not going to get the same measure. The central angles only occur if they intersect over here at the center. But since they're not intersecting at the center, you are going to get different measurements for the intercepted arcs. So let's take a look closely at the relationships. So these are not changing. So we still have 31 and 31, and together that's a sum of 62. Now, if we look at the intercepted arcs, they are different measurements, but their sum is still 62, still the same. Now, let's see what happens as I move it around. So again, keep your eye on the angle measurements and keep your eye on the sum. So as you can see, as I move this around, the measurements of the arcs keep changing, but the sum stays at 62, no matter where I go. Okay, so I hope you've come to the conclusion that the sum of these two angles are equal to the sum of these two angles. So here we have 17 and 45, and 17 and 45 is equal to 62. And in here, inside the vertical angles, we have 31 and 31, and 31 plus 31 is equal to 62 as well. So no matter where I go, I'm going to have the relationship of these two arcs having the same sum as these two angles. Let's say I knew that this was 28 and this was 34, and I was looking for the measure of angle X. Well, how would you find that measure? Now, you know it's not 34 because X is not a central angle. So 34 is not its measure. But we do know that this angle over here is also X because they have the same measure. And we know that these two angles, these two X's, have the same sum as 28 and 34. So how would I go about finding X? Well, one way you can go about finding X is we know that the two X's add up to 28 plus 34. That should be a plus. A 28 plus 34 is 62. 2x is equal to 62. And so therefore x is equal to 31. So what did we do here? We added these two angles together, right? And then we divided by 2. So let's take a look at making up a formula for such a situation. So let's say I told you that this was y, and this was z, and this was x. How would you describe the relationship? Well, there's several ways you can go about it. One way is we know that these two angles on the inside are congruent. So I can say that x plus x is equal to y plus z, right? And I can simplify that to 2x equals y plus z. Now, how do I simplify this for x? Well, I could divide each side by 2. So x is equal to y plus z divided by 2. In other words, if I add the two intercepted arcs, the measures, if I add the measures of the intercepted arcs, y and z, and then I divide by 2, I get the measure of one of these angles. Let's say I'm somewhere over here and I'm looking for the measure of x, this angle right here. All right, and according to this, I have a degree of 17 over here and 45 over here. So I know that if I add these two arc measures together and then divide by 2, I'm going to get x. So let's try that. 45 plus 17 equals 62. And then if I take that 62 and divide by 2, I get 31. And notice that, okay, and notice that 31 is the correct measure for those angles. All right, so no matter where I go, if I take the two arcs that are over here and over here, and I add them and I divide by 2, I get the measure of this angle. So I'm going to move this around a little more. Let's say we're over here. And let's say I told you that this was 31 degrees and this is 46. And we were looking for x over here. So what do we know? We know that this arc plus this arc, the measures of those two arcs, added together and divided by 2 will give you this. Or if I take 31 degrees and double it, I'm going to get this sum, 46 and x. So you can go about this two different ways. You can set this up as 46 plus x. We know that if we divide the sum by 2, we get 31. Or you can double the 31. We know that 2 31s is equal to 46 plus x. So you can start it off two different ways. So let's see what happens on the left. On the left, I'm going to multiply each side by 2. So 46 plus x equals 62. And notice I kind of have the same equation that's here. So subtract 46 from each side, x is equal to 15 degrees. If I'm over here, I'm going to get 62 equals 46 plus x, and notice I'm basically doing the same thing. X equals 15. So basically that's all there is to it. The angle that's over here and the angle that's over here, their sum is equal to the arc measure over here plus the arc measure over there, okay? No matter where the intersection is on the circle. Let's go to the notes and notice here we have circle O with secants PQ and RS, and they are intersecting inside the circle. Now, remember that angle 1 is congruent to angle SEQ, and also the sum of angle 1 plus that angle is the same as the measure of arc PR plus SQ. Now, notice that the formula that they're giving you is that the measure of angle 1 is equal to half of the sum of these two, which is something that we talked about. Let's go to exercises. For number 1, I have 40 degrees right here. That's the measure of that arc. 52 degrees right there, and we're looking for the measure of angle 1. So based on what we did, the measure of angle 1 is equal to 40 plus 52 divided by 2, because remember, angle 1 plus this angle over here together have a sum of 40 and 52. So to get just angle 1, we need to divide by 2. So we're going to get 92 divided by 2, and that's equal to 46 degrees. Another way that you could have done this, if you're looking at it the other way, is you could have had met two angle 1s and said, let's call it x. And we could say that 2x is equal to 40 plus 52. And 2x is equal to 92. And when you divide both sides by 2, you still get 46. So depends on how you look at it and what makes it easy for you. If you don't like seeing that half, you can do it this way. Let's move on to the next one. So here we have 28 degrees FE. GH, we don't know. That's what we're looking for. So I'm going to call that X. And we have 45 here. Now you can go about this two different ways. I'm going to show you both ways to do it. One way is we know that the 45-degree angle is equal to x plus 28 divided by 2. Now we're going to multiply each side by 2. Cancel over here. We've got 90 equals x plus 28. Subtract 28 from each side, and x is equal to 62 degrees. Another way to do this is we know that these are vertical angles and both of them are 45 degrees. So 45 and 45 is 90. And 90 is equal to 28 plus x. Subtract 28 from each side, x is equal to 62. So if you don't like seeing that half, you can always do it this way. Now let's do a check. We got 62 degrees for that arc. So does 62 plus 28, those are the two arcs, equal to these two angles put together, or 45 times 2? Well, this side is 90, and 62 plus 28 is also 90. So that's a check. So that's a good way to check to see if you got the right answer. Because remember, the two arcs and the two angles have to add up to the same thing. Now, here's something we did not do on Geometer Sketchpad, but I'm going to show you logically how you can figure it out, and that's number 3. So if you take a look at this one, we don't really see the two secants, but they are actually there. If you take this ray and turn it into a line, and you take this ray and turn it into a line. We actually do have an intersection. It's not really secants, but we do have an intersection. One of them's a secant, one of them's a tangent, but the idea is exactly the same. So let me show you what I'm looking at. So we're looking for the measure of angle 3. So let's take a look at our intercepted arc. Here, we are intercepting this arc right here, okay? And on the other side, we are intercepting over here, we are intercepting nothing. So there is no arc here. That's nothing. So really, essentially, what we have is 220 degrees plus nothing is equal to 2 times angle 3, which is, we'll call that x. 2 times angle 3. So 220 is equal to 2x, and therefore x is equal to 110 degrees. So in other words, if I extended this, then I have 110, 110 here and here. Okay, so in other words, this arc is the only arc that we are looking at, because this angle over here doesn't intercept any angle at all. So it kind of has the same logic to it. So here for number 4, I again have a tangent with a secant, and I have an angle of 74 degrees, and therefore this is also 74 degrees. Now, if, I'm looking for the measure of arc RT, that's our x. Now, first of all, our angles, 74 and 74, add up to 148, right? And that means that our arc here, plus whatever arc was here, has to add up to 148. But there's no arc there, which means that that's 0, which means this arc right here is the entire sum. So this has to therefore equal 148. Now, the way you can look at problems where you have tangent and secants is you just take the arc and divide it by 2 to get the angle, or you take the angle and multiply it by 2 to get the arc. So let's take a look at this one more time. You can do here 74 times 2, and that will give you the measure of the arc, measure of RT. All right, and that's as simple as that. So if you have a tangent and a secant, and you want to find the measure of the arc that they intercept, you just multiply the angle that they make by 2. All right, let's go on to number 5. Now, number 5 is the other type of problem. So here we have 90, 130, and we're looking for the measure of angle 5. So that's a little different. Remember that angle 5 really has nothing to do with those two angles, so we have to put angle 5 on the side for now, and we're going to go right here. We're going to call this x. Now remember, these two are both x's, so 2x is equal to 90 plus 130. Or you can say 90 plus 130 divided by 2 is x. Whatever is easier for you. So here I have 2x is equal to 220. So x is equal to 110. So I know that that angle right there is 110. But that's not the end of the question. Now I have to figure out what is angle 5. Well, as you can see right here, we have a straight angle. So if that piece right here, this x, is 110, then if you subtract from 180, you get the measure of angle 5. So the measure of angle 5 is 70 degrees. For the last question, we have a secant and a tangent. And again, you can do this the fast way. They're asking us for the measure of angle 6. Okay. So the first thing I'm going to do is I'm going to figure out, well, what's the measure of that arc? Well, on this side, we have 160 degrees. The entire circle is 360 degrees. So if I take away 160 degrees, I'm left with 200 degrees. So I know that this arc is 200 degrees. Now remember, the angle that's intercepted is half of it. So measure of angle 6 is equal to half of 200, which is 100 degrees.